Perhaps the single most important character in the U.S. transonic aircraft program was that of Ezra Kocher. As early as 1939, Kocher had proposed that the Army Air Corps sponsor the development of a transonic flight research program. His proposal at the time was not given much attention, as such speeds were virtually unheard of. 4 years later, following the revelation of compressibility problems at high speed with the Lockheed P-38 and Republic P-47, a new interest in transonic flight was awakened. By early 1933, Kocher renewed his work on transonic aircraft and began a study comparing the merits of rocket versus jet propulsion. As jet technology was in its infancy, he concluded that a rocket-propelled research aircraft would offer superior performance and versatility. NACA, believing that a rocket engine was too dangerous, requested Kocher to consider the use of a turbojet design. Kocher insisted on the rocket motor, while the Navy, working on their own independent transonic program, did adhere to NACA's concerns. The result was the D588-1 Skystreak, which proved a successful research platform, however failed to achieve supersonic speed in level flight. By the summer of 1944, Kocher received permission to find a contractor and to begin development on what was then known as Project MX-524. This proved more difficult than expected, as the U.S. aviation industry was in full swing mass-producing combat aircraft for the war effort. It wasn't until November that Kocher found an interested contractor after talking with Robert Woods, an engineer from Bell Aircraft Corporation. Once again, Bell suggested the MX-524 project be visualized in terms of turbojet propulsion. However, after a series of engineering team studies, Bell agreed upon Kocher's rocket-powered design. In 1945, very little was known about aerodynamics at supersonic speed. After a generally disappointing tour of various aerodynamic research institutes across the United States, the design team made a stop at the U.S. Army Air Force's Ballistics Laboratory at Wright Field. Discussions with the ballistics experts and armament specialists lead the design team to study a .50 caliber bullet. While little was known about the aerodynamics of the bullet, there was no question about the fact that it was stable at high speeds. It was this stability that was the inspiration behind the fuselage shape of what would later become the X-1. While aware of the benefits a swept wing provides at high speed, little more was known about the stability of such a wing. The X-1 was built with stability and safety as its primary function, and speed as its secondary, so Bell opted for a more familiar straight-wing design. Later on during the project, and during the preliminary concept testing for the X-2, Bell conducted quarter-scale wind tunnel tests on a variety of different wing configurations, including even a forward-swept configuration. The wings themselves would be an engineering challenge of their own. To minimize aerodynamic drag, the wings were made extremely thin, ranging from 8 to 12% thickness as modifications were made throughout the project. With a focus on pilot safety, the wings were clad in unusually thick aluminum, designed to be capable of sustaining 18G loads. At the wing roots, the aluminum surface was half an inch thick, which gradually slimmed to a more conventional thickness at the wingtips. This thick skin, while adding weight, would also keep its smooth contour through the turbulent flow that developed at transonic speeds. By March, the aircraft earned an internal designation as the Model 44 and received a new project designation, XS1. The XS1, which stood for Experimental Sonic 1, was given a high priority and classified status. Development would progress quickly, and the first prototype would roll out of Bell's Wheatfield, New York plant less than 10 months later on December 27. The Army had selected Pine Castle Field in Florida to conduct the initial unpowered glide tests. Instead of the rocket engine, which was not yet ready, the X-1 was fitted with a ballast to mimic the weight of the engine. The X-1 would be flown to Pine Castle in January 1946, mated to a Boeing B-29 carrier aircraft. By the 24th of that month, Bell's chief test pilot, Jack Willems, would conduct the first unpowered flight of the X-1. During this flight, the B-29 mothership carried the X-1 to an altitude of 27,000 feet before being released from the bomb bay. Willems reported a clean break. The flight would last only 10 minutes, where Willems achieved a top speed of 275 miles per hour, reporting that the aircraft was responsive and extremely easy to fly. He would go on to conduct another 9 unpowered flights between January and March, before a decision was made to move the project to Muroc Field. At this time, The X-1 was returned to Bell to be fitted with a new, even thinner wing. The original, thicker wing was removed to be installed on the second X-1, which was preparing for the first powered flights of the program. Unfortunately, Jack Willems, who had been expected to fly the initial powered flights, was killed in an unrelated accident in August when his modified P-39 Cobra 1 crashed into Lake Ontario while practicing for the National Air Races. While the first X-1 was undergoing the wing modification, and more importantly, the engine installation, the second X-1 was ferried to Muroc Field, ready for powered flight tests. Now with test pilot Slick Goodlin at the controls, the number 2 aircraft was put through 3 uneventful glide tests before being submitted for powered flight. By the end of February 1947, Goodlin had conducted 12 powered flights, attaining speeds up to Mach 0.82. The number 1 aircraft was delivered to Muroc that spring and conducted its first powered flight on April 11. In mid-1947, Bell became concerned about the financial responsibility of the program. In the post-war years, the research and development budgets had been slashed to almost nothing. The Air Materiel Command, or AMC, lacked the funding to continue to support a contract with Bell to conduct the program. Not to mention, Bell's test pilot was asking for a $150,000 payout over the course of 5 years, over $2 million when adjusting for inflation. Following the initial powered test flights, the Air Force took over the X-1 program under the leadership of Colonel Albert Boyd, chief of the Flight Test Division at Wright Field. By May, Boyd had selected Captain Charles E. Yeager to be the chief test pilot of the program. While he lacked a college education, Boyd considered Yeager to be the best instinctive pilot he'd ever seen. By July, chief test pilot Chuck Yeager, backup test pilot Bob Hoover, and project engineer Jackie Ridley were assigned to Muroc Field to begin the Air Force controlled test phase. Bell test pilot Dick Frost was also brought onto the project, as he'd been working on the X-1 since it was on the drawing board. Frost would spend 4 days teaching Yeager, Hoover, and Ridley everything he knew about the X-1, familiarizing them with the aircraft. On August 6, Yeager would conduct his first unpowered flight in the experimental aircraft. Due to a parts shortage, installation of the rocket motor had been delayed, and the aircraft would once again be fitted with a ballast for the flight. This time, Yeager would conduct his glide test from an altitude of 18,000 feet and would conduct a series of slow rolls during the 8-minute descent. Much like Willems, Yeager said that the aircraft was graceful, responsive, and beautiful to handle. 2 days later, Yeager would conduct the final glide test, where he engaged Bob Hoover, who was flying a Lockheed P-80 as a chase plane, in a mock dogfight. A shortage of parts continued to delay the program, and the rocket motor would not be installed for another 3 weeks. It was not until late August 27th that ground trials could be conducted with the engine installed. 2 days later, Yeager's wait for an eagerly anticipated powered flight was over. Aboard a B-29, Yeager and the X-1 were carried to an altitude of 25,000 feet before the B-29 nosed over into a shallow dive. At an altitude of 21,000 feet and an airspeed of 255 miles per hour, the X-1 was released. After about 10 seconds of freefall, Yeager ignited the first chamber of the engine. 5 seconds later, he would ignite the second chamber while shutting down the first. He would repeat this procedure for each of the 4 rocket chambers. At one point during the flight, Yeager executed a slow roll and briefly attained a 0G attitude, causing the rocket engine to shut down due to a drop in tank pressure. Yeager was able to reignite with ease and put the aircraft into a climb to 45,000 feet at Mach 0.7. After leveling out, Yeager once again shut down the engine, rolled over, and started a high-speed, unpowered descent. After recovering from the dive at 5,000 feet, Yeager reignited the number 1 chamber and put the aircraft into a shallow climb. Then in rapid sequence, he ignited the remaining chambers. Now pushing the rocket engine to its full output for the first time, Yeager once again climbed to 35,000 feet, accelerating to Mach 0.84. The flight plan Yeager was expected to abide by stipulated that he should not exceed Mach 0.82 on this flight. The NACA team later questioned Yeager's sense of discipline. In Yeager's report, he had attempted to keep the speed below the required Mach number by putting the aircraft into the climb, but the aircraft showed no sign of slowing down as it effortlessly continued to accelerate. After a solid scolding from Boyd, Yeager was permitted to stay on the project. Come October, Yeager and his team were preparing for the ultimate test to reach the speed of sound. NAC engineers warned them not to exceed Mach 0.96 unless Yeager was unequivocally certain that it was safe to do so. On Tuesday the 14th, the aircraft was fueled before being hoisted into the bomb bay of the B-29 mothership. A thin white layer of frost had formed around the center section of the aircraft as the supercooled liquid oxygen was injected into the aft tank. By mid-morning, the B-29 departed Muroc's primary runway. Halfway through the climb to 20,000 feet, Yeager painfully climbed into the cockpit of the X-1. Unknown to anyone other than Ridley, Yeager had suffered a few broken ribs during a horseback riding accident at Poncho Barnes only 2 days prior. Fearing that he would be grounded by the flight surgeon, Yeager opted to visit a civilian doctor off base, keeping his injury secret. Once at altitude, Ridley pulled the release mechanism, dropping the X-1 over the desert. With an airspeed of 250 miles per hour, the drop was slower than desired, so Yeager put the X-1 into a shallow dive to pick up speed. He then ignited all 4 rocket chambers in rapid sequence and accelerated upwards rapidly. As he approached Mach 0.9, Yeager shut down 2 of the chambers to test stability and control at a high transonic speed. Satisfied with the proven stability and now at 42,000 feet, he reignited the 3rd chamber, effortlessly accelerating past Mach 1. As either a simple oversight or lack of faith in the program, the Mach indicator in the X-1 only went as high as 1.0. As the needle went off the scale, Yeager extrapolated a speed of Mach 1.05 on the assumption that it continued linearly after passing the Mach 1 mark. Yeager sustained supersonic flight for 20 seconds before shutting off the rocket motor and jettisoning the remaining propellant. Yeager would go on to make another 30 flights in the X-1, achieving speeds as high as Mach 1.5 at altitudes up to 70,000 feet. By 1950, the number 1 X-1 was retired and delivered to the Smithsonian Institution. Only one conventional takeoff would be conducted in the X-1 as a form of competition between the Air Force and Navy. The Navy claimed that their supersonic platform, the D-588-1, was a real airplane because it landed and took off conventionally. In January 1949, Yeager performed the only conventional takeoff in the X-1 just to prove it could be done. Ironically, while the D-588-1 failed to reach supersonic speeds, the Navy opted for an air launch system for their own rocket-powered D-588-2. The number 2 aircraft would continue to fly for another year before it was permanently grounded due to rusting and battery acid leaks. This airframe was noticeably slower than the number 1 aircraft due to the thicker wing. The fastest speed recorded with the number 2 aircraft was Mach 1.2. A 3rd X-1 would be delivered in April 1951, 3 years behind schedule. This aircraft made use of a new steam-driven turbopump used to transfer propellants to the power plant. This was considered a significant technological step forward, as the first 2 aircraft used a high-pressure gas system that was considered more dangerous. The number 3 aircraft would perform its first unpowered flight on July 20th, 1951, with NACA pilot Joseph Cannon at the controls. This would be the only successful flight of the number 3 airframe. Its second and final flight was conducted in November, this time carried by a B-50. This flight was intended to be a rehearsal of the drop procedure. Prior to the release, Cannon attempted to jettison the propellant. However, there was a failure in the nitrogen pressure system, preventing the fuel jettison. Concerned about landing with a full load of fuel, something the landing gear on the X-1 was not designed to handle, a decision was made to abort the drop and land the B-50 with the X-1 still aboard. After a successful landing, the nitrogen tank was repressurized and the propellants were jettisoned. During this process, the X-1 experienced a series of explosions, varying in intensity. Both the X-1 and the B-50 were completely destroyed, but miraculously no fatalities occurred. This marked the end of the first generation of the X-1. The success of the X-1 demonstrated that faster-than-sound flight was indeed possible and would usher in a new generation of supersonic aircraft. It would also start a new and immensely influential series of purely experimental aircraft, known as the X-planes. While the first generation of X-1 only flew for a few years, operating between 1946 and 1951, the second generation would operate as late as 1958 with the X-1E. While this concludes the story of the X-1 itself, we will go over the second generation, covering the X-1A through the X-1E in a future video. I hope you stick around, and thanks for watching.